All right. Good afternoon, everybody. Thank you for choosing this talk as your after-lunch talk. Now, I know that after a big lunch, we kind of trying to get sleepy, and so I'm going to try to keep the energy levels up here to hopefully help you keep your energy levels up too. I just wanted to take a moment to say thank you to the organizers and the track hosts and everybody working behind the scenes. But most importantly, I want to say thank you to everybody, the community that is here, everyone, and the community at large. Without everybody here, like we couldn't do this. We couldn't have a KubeCon. So, my name is Jesse Deering. I'm a site reliability engineer at VMware. I work on the Tanzu Mission Control product, and I love working with systems, infrastructure, building the tools to manage systems and infrastructure. And so I get to work with a lot of Kubernetes at VMware, which is really exciting. I've been working with Kubernetes since 1.6. It's when I first kind of got it installed and was using it in production. I actually changed jobs, and they were telling me, oh, we run all this stuff on Kubernetes. I'm like, oh, that's cool. What is that? And I looked into it, and I was like, oh, this is nice, because previous to that, I had been running Docker in production. I was running Docker in production at 0.11, so I've seen some stuff. It was rough. And I guess you could say I've been doing cloud native before we even started calling it cloud native. So events, the thing that inspired me to put this talk together was I was working on an operator, and I had a piece of information that I needed to somehow emit out of like the cluster, but it didn't make sense to use a Prometheus metric. It wasn't really a metric that I had, and I could emit it as a log line, but I needed to come back and look it up later, and having to grep through logs didn't seem like an adequate solution either. And so, as I was looking around and reading the documentation, I came across the Events API in Kubernetes. Now, I was already kind of on board with it, just reading the first few sentences, because I already liked the idea of streaming and evented sort of constructs and things like event sourcing architectures and stuff like that. That stuff has been really interesting to me. And so, by coincidence, I found that one of my colleagues, who also works at VMware, Michael Gash, wrote Events, the DNA of Kubernetes. And I was really kind of getting on board with this idea of emitting and consuming events about the cluster, inside the cluster. But before we get into that, I just want to do a quick rundown of what events are. Now, can I see, just by a show of hands, how many people have used events in Kubernetes before? Okay, good, a lot of you. I'm going to go ahead and just do a quick recap of what events are and kind of what they look like inside the cluster. So whenever you run kubectl describe, you can run it on any sort of resource that is in the cluster. So in the example here, I've run it against a pod, a Contour pod. And just for reference, Contour is, it's an open source project that we have that uses ingress objects and talks to Envoy, and Envoy is the web server, and so it updates Envoy using ingress objects from the cluster. So basically a web server. It's like the hello world for Kubernetes. But I mean, Envoy is a little bit more complicated than that. So this particular event is an unhealthy event because of readiness probe failure. As you can see from the output of the message up here, it's failing because of an HTTP 503 code, which just basically means the web server is unavailable. I did this on purpose just to try to get it to emit an event. But this is KubeCon. We don't do things in tables. We do them in YAML. So here is what an event looks like in YAML. So we all know the API version and the kind. So it's v1 and event, respectively. But I wanted to call out that events have counts. And so whenever you see the output here in the column, the spreadsheet type form, you can see that it's got 60 seconds as the age of this, 9 times over 84 seconds. Well, so the count there is 9. You can see the first timestamp and then the last timestamp at the bottom. And that's where it gets the first time that it was emitted and then the last time that it was seen. And you can see here in the middle, too, there is the involved object. And I'm going to get more into that in just a second. But one of the things that I do like about this involved object is even though this is talking about a pod specifically, there's this field path that this field path that tells you specifically the subject of this event is the Envoy container inside of that pod. So one problem with YAML is that it takes 2 slides for me to show you everything. So this is the second part of the event. And I've grayed out the stuff that's not really important, just the metadata of the event. But every event has a message, and the message gives a lot of context as to what the event was emitted for. So in this case, this is the 503 error code. The next field that I'm going to call out is called reason. This is more of a type with events. The problem is there's already a type field. But a reason is just a short sort of type of this event. So you could think of this as the reason here says unhealthy. This is an unhealthy event. It's, I think they already use type for what type of, so let me jump to type real quick. Type, it can either be normal or warning. So it's either, a good event or something has gone bad, which again, I would think it would be normal or error, but names are hard. So I want to talk a little bit about some of the conventions and the defaults for events. So if you do list the events in your namespace, you'll notice that most of them have the name of the object with a period and then some sort of unique ID or hash at the end. I actually don't know how they get that in Kubernetes. It does always, in my cluster, seem to start with 15. I don't know why that is. But an event could be named anything that you want, but this is the convention for it. All events have a time to live of 1 hour. At least that's the default that is set in the Kube API server. You can always change this with the event TTL flag, but 1 hour is the default for events. And then events are a namespaced object, so while they can still refer to objects that are at the cluster level or maybe even in different namespaces, the events themselves have to live in a namespace. So the question is then, what can we do with these events now that we know what they are and what they look like? Well, we can emit. We can emit our own events. And so to do that, we need to build an event object and use the Kubernetes API. Every event requires an involved object, and what this means is every event is tied to something that already exists, whether it's a deployment or a pod or even a namespace. The event cannot exist on its own. And as I said before, events are a namespaced object, so they can involve any object that exists in their namespace, or they, again, can use other namespaces, but they themselves can't live at a cluster level. So I write a lot of Go. I love Go, but it's been a long time since I've touched Python. So when I tried to work and write something for this talk, I decided I was going to use the Python Kubernetes client. Another reason for that is I think that Python also presents better. Go is a little hard to follow. You kind of have to really look at the snippet in full. Where with Python, I feel you can kind of, you can leave some stuff out and people can still get the gist. So for the following code examples, I use the Python Kubernetes client, and I'm just using CUIDs at the end. Those are just collision-resistant, unique IDs. But what I'm going to show right now is doing a lookup of a deployment in a namespace, and then we're going to take that and we're going to emit an event that references that deployment. If the code samples are too hard to see in the back, I have uploaded the slides, so you can pull them up there. And also, I'll be sharing a link with all the code at the end. So here it is. You can see in the first thing that I do is I do a load kubeconfig. This is pretty similar to what you would do in client Go as well. I've commented out the load in cluster config. Sorry, it seems I'm losing my voice. The load in cluster config would be if you were going to run this inside of a pod with a service account. You would just use that to load its access to the cluster. So the next thing I'm doing is I go and I'm finding the deployment UI server, which in this case is just Nginx, in the TMC Deering J namespace. So the first thing I'm going to do after that is I want to record the time that I saw the event. So that's what this is doing. It's important to note that you need to always include the time zone. The Kubernetes API will not accept it if it doesn't have a time zone in the string. And to do that in Python, you have to use date time now and pass in the time zone. And UTC is just a good time zone to pass in because most of servers that we run are on UTC anyway. So everything's in UTC just to avoid confusion. Okay. So the last part of this sample is building the involved object. And all we're doing is we're taking what we got, all the information about the deployment, and so we're setting API version, kind, name, namespace, and I want to call out something really important. In order to get this to show up in kubectl describe, you have to include the UID and the resource ID as well. So if you just try to do it as a deployment by name, you'll see the event, but you won't be able to look at a describe of a resource to see it listed at the bottom. And so now we're ready to go ahead and build our event object to put into the cluster. So again, I set my involved object to everything that we've set up previously. And I set the first and last timestamp. And then finally with the metadata, I set the name of the deployment, UI-server, period, CUID, namespace, all that. The other thing that you can do that's interesting with events is that you can declare the source. Now, a lot of what we see when running clusters is we see events that are emitted by kubelet, mostly. Like the last one that we were looking at was the readiness failure, and that was emitted by kubelet with the host. But the source can have any component name. And so in this case, I'm just going to put in CI approver. And it's a normal event, so it's not an event that is concerning. And the reason is this is an approval event, so it's the reason is approval. And then the message can just be anything that you want to provide context around the event. So in this case, it's just manually tested and approved. And finally, at the end, we emit the event into our cluster. So this looks like whenever we run our Git events, we see the last seen time, again, that comes from the first timestamp, or the first seen timestamp. Type normal. We see now our reason that we set, and we can see it's correctly tied to the deployment UI server. And then we see the message. But this is what it looks like now in the context of describing the deployment. So usually when you run describe, you get a ton of very useful information. And then at the very bottom, under the events section, you see all the events that are tied to that particular object. In this case, we have everything that you saw in the previous slide, except for the from field. This is where it is using our component that we set up in the source. All right, so that's it. That is how we emit events. So the next step is once we're emitting events, we need to be consuming them. So I want to talk a little bit about making your own controller for consuming events in Python. Do we call them controllers still, or are they operators now? I really can't keep up. I try, but I can't. So I'm just going to call it an event consumer. So let's look at one made in a few lines of Python. I want to quickly say that there's a lot of serverless type of applications and frameworks and tools coming out that let you, like Knative is a good example, that let you write functions, just like you would in sort of a Lambda type environment, and that function gets executed for each event that gets created. So you may or may not need to do this. Most of the time, this is going to be pretty simple to do. Maybe you don't need Knative right now, but if you're using Knative, you already have this ability. So this is it. This is, 7 lines of Python. And all we're doing is we're, again, loading our kube config, and then we're establishing a watch on the namespace resources, the events in the namespace. And so each time an event comes in, the code in this for loop gets executed. Right now, I'm just printing out the event, but this is where you would say act on whatever the event is doing. There are also third-party event consumers that can help you. One of the things that we did, I came to VMware from Heptio, but we still have our Heptio labs out there. One of the things that we put into the Heptio labs repos and the Heptio labs GitHub organization was Event Router. And Event Router has a number of what they call sinks, which are just basically places to send events. The default is standard out. And it's standard out because it assumes that you're running fluentd. You get those logs slurped up into whatever your logging solution may be, your elk stack, logly, logz, Humio. We have a ton of tools for logging. It's really great. But this lets you do that. It also will emit events into S3 and Kafka, and even it'll make an HTTP call to a service that you have running. So if you don't want to write anything against your Kubernetes API, you can use this to just have it send an HTTP call to your own running service. Then the other neat thing that Event Router does is it emits Prometheus metrics. This is going to be something that I'm going to touch on next, which is after we have consumed our events, let's talk about how we can present them and use them in a way that isn't just acting on them, but kind of looking at them in aggregate. So there's Heptio Labs Event Router that creates Prometheus metrics, but there's also KubeCloud has an event exporter that will do basically the same thing. And once we pull these into Prometheus, we can do things like, we can sum on these events, kind of get an idea of counts. We can look at events over time in a time series graph. It becomes a way that we can now sort of manage some of these things that we see going on in our cluster. I wanted to call out, there is a talk tomorrow in the 11:50 time slot on Thursday called Exporting Event Objects for Better Observability. It's going to be given by Mustafa Akin and Amit Shaker, and it's going to be in room 16 on the mezzanine level. They're going to talk about all of the cluster events that you can look at and you can monitor. And I also believe that they're going to be releasing an open source tool that you can use to help observe those events as well. But as it stands right now, we also have monitoring providers that help you see these events as well. So if you're running on Google Cloud, Stackdriver is already showing you these events. Datadog, the Datadog agent pulls these in as well. Or if you set up Event Router, you can pull these in with FluentD. These are just the 3 where I've seen it and I've used it. This is by no means an exhaustive list, so there's quite a few more out there. But the types of events, and I'm not going to go into this too much because I feel like the other talk I think will better explain the type of events in the cluster that you can look for and monitor. But the types of events that you can see in a cluster are liveness and readiness probes, as we've already seen. Back-off events, so whenever you see those pods and crash loop back-off, if you check the events, you can always see why it ended up in crash loop back-off. Job creation and completion for your cron jobs or your stock Kubernetes jobs. And then you can see scheduling problems, or maybe not even problems, just what's happening with the scheduler. So this is a way where you can find things like, do you have enough capacity in your cluster? Or when it tried to schedule that pod, did it fail to schedule because you don't have enough resources? Or is there a typo in the image name? Or maybe the image doesn't exist, and that gets emitted as an event that you can then consume and alert on. So now, I want to talk a little bit about custom events and what we can do with that inside of our own clusters. So the kind of use case that I was thinking of, that I put into the code that I'm going to share at the end, was an automated deployment for environments that need approvals. Maybe you have an environment that requires, like, every manager has to approve. It's typical for a lot of compliance things that you need to maybe have someone else approve a deployment. Or maybe you have a end-to-end test suite that you run in another environment that you want to ensure has run and passed before you deploy something to production. So we're going to use an event to approve a deploy. And on top of that, the way that we're going to enforce it is we're going to use an admission webhook to make sure that if we don't have that approval, that we will not allow the new pods to come online. So I'm going to take some excerpts from the webhook, but basically what it's doing is when you establish it and you configure it using the admission webhook object, is it's going to listen for operations on replica set resources. The one operation that we're particularly interested in is create, because when a deployment creates when you change an image or something like that, it creates a new replica set behind the scenes. And so it's going to check those deployments first for the approval, and then it'll create that replica set. So this is what's required to do that. All we're doing here is we're going and we're looking at all the events. We're finding them for the particular deployment, given the deployment name in the involved object, and we're looking to see if it's approved. If this event exists, then we'll return a true and we'll allow the replica set to be created. Otherwise, we'll return false, which should deny the replica set from being created. And this is what that response looks like. It's a simple bit of JSON that we send back where we say, in our admission review, is it allowed or not? And if it's not allowed, we set a status to say, okay, the code is 403 using the HTTP forbidden code, and the message is your deployment needs to be approved. So let's see this in action when we try to edit our deployment to change the image or something. This is what you'll see. It gets emitted as an event. So again, turtles all the way down because you got an event now that's getting emitted as an event. So, but you can see that it was denied the request to create the replica set. This is the deployment itself. So the deployment was changed. Kubernetes said, okay, I'm going to make a call to the API to go create a new replica set. But then it got denied because we didn't find that, and we denied it in our admission controller. So in this case, I would run the end-to-end test. It would pass, and then I would generate that approval event, and then I would try to deploy again. In which case, you see now the first event that I have is the approval event, and then the deployment goes ahead and creates the replica set. Scales down the old one, scales up the new one. Other use cases I think that we can think of using events for is relating any sort of external state to Kubernetes objects. So one thing, and this doesn't exist, but I would love to see it, is if you have some sort of ping test, like similar to what you get with, say, like Pingdom, where whenever it fails, it creates an event on your ingress objects. Maybe you're pinging certain URLs that go to certain services. Wouldn't it be cool to put an event on those ingress objects to help you debug a little bit faster? So you can say, okay, Pingdom's failing for this one particular area of our application. Let's go look at the ingress object. Oh, okay, and we can see what service it's related to. And assuming that its liveness checks and readiness checks are passing, you maybe have deployed a bug and you know faster to roll back. And again, the use case that started this all for me was logging operator changes to cluster objects. So if you are writing your own operators, logging these things, you're already creating Kubernetes objects with your operator. Using events to be able to log maybe if it's changing, if it's pulled a certain image down, or if it has updated some sort of configuration. Being able to log those with events from your operator can be really helpful in helping you debug and having a better observability in your cluster. So, in conclusion, in summation, events, they are deleted after an hour. They don't stick around very long. Every event can't exist without some sort of involved event, as it's called, but it has to refer to some other event, or some other object. And to get them to show up and describe, you have to be very careful about making sure that you relate all of the pieces, including UID and resource version. And events themselves are very easy to consume in both client Go and the Kubernetes Python client using watches. And then finally, there are a lot of great monitoring and logging tools out there to capture events, log and alert on them, to increase your observability for the things that are going on inside of your cluster. So that's it for me. Thank you so much for attending my talk. And like I said, I wanted to post here. If you have any questions, you want to hit me up on Twitter. I blog maybe once a year at jesse.dev. I need to get back into it, but then I said that last year, and here we are again. And then the source for this is all up on GitHub. So thank you. Oh, and if you have any questions, the mic is going around.
Hi, thank you for a great introduction to events. So whenever I upgrade my Kubernetes cluster to the next version, I see some new events related to a pod. Initially it was 3 or 4 of them, like container init and stuff like that, and I knew all of them, and now there are like 20 of them or something like that. So they keep adding various events. Is there a centralized event catalog or like a state machine driving where I can see if pod is that state where it can go, or what was the root cause? Because I mean, there is a huge amount of events right now, and I don't have a clue like what they mean.
The best that you can do with that is maybe, I know that if you just try to say, look at the events across all of your namespaces, you maybe don't get the full context for what's happening. And so a lot of times what I've found is the event will kind of set me in the right direction. Like maybe it'll say a pod was terminated, because of, something. It's not very specific as to what. But if I could find that pod, I could go and I could describe the pod and look and see, oh, it's getting killed or something like that. And so events kind of act as breadcrumbs to sort of send you to, a better place to sort of debug problems in your cluster. But other than that,
Just hope that their names are readable.
Yeah, you got to hope that the names are readable and it kind of sends you in the right direction.
Hi, Jesse.
Hi.
So I'm part of the VDP team, so VMware Developer Platform, part of CPSBU. So we have a use case where we have a similar tool, event router, which creates Jira tickets in an air gap environment from the alerts which are coming in from Prometheus Alert Manager or any other source like Wavefront as well. So just one thing I wanted to ask, if we have multiple tenants on the same cluster, and we are kind of creating a config map reloader, like tenants have access to their namespaces, they can upload their configs here. I would mean like Jira credentials and the queue names. Like if I want tenant A alerts to be routed to that specific endpoint, tenant B alerts to be routed to a different endpoint as per the configs that they are adding. So is that capability also there in the event router as of now? Or?
I think so. I don't. I would try to repeat the question, but I don't. I guess you were mic'd up, so that's okay. I don't. I think what you could probably do there is you could centralize the events in some sort of a particular namespace. It doesn't have to have anything else other than just the events that you care about, and so you could log those events into that namespace and reference events from others. I think that's probably the best that you could do. Does that answer your question?
Okay, so you're saying that we can kind of create a new namespace where we can add logs. But the question that I wanted to ask was, so we can put the logs in one namespace or events that come in, but if we have to write some events onto a different endpoint, route some events to a different endpoint, and some to another endpoint. So can we do that? Like, do we have that capability as of now in this?
Yeah, events, they just are Kubernetes
Different
objects.
syncs.
So yeah, they can be portable from, one cluster to another, one endpoint to another. So it should be pretty easy to create something, whether it's an HTTP call or you're maybe reading off of a Kafka topic to support.
Okay, so we can create custom syncs for that and then plug there. Okay, cool.
Yep.
Thank you.
Thank you.
Yeah, I just had a quick question about the usage of reason versus like type. Is there any guidelines or ideas on what to put there? Because like one you had approval, and another one you just like had like replica set error or something like that. Like,
Yeah,
have you seen any patterns in that?
Yeah, that's a great question. So the best thing that you can do there is try to keep it short, and if you're pulling them into Prometheus, kind of keep them the same so that you don't explode the cardinality of like your Prometheus monitoring. Because if you're saying like, if you're trying to like, if you put the name of the pod in the reason, that could explode your cardinality or something like that. So just keeping it short, also so you can kind of look at it at a glance in the Kubectl list and describe and things, and then also making sure that it really kind of describes what the event is, like what's kind of basically what reason is kind of a good name, because it's why does the event have the, like what's the reason for the event to exist. So if it's in the case of a failure for a readiness check. It's a readiness failure or whatever it's called in Kubernetes.
Thanks.
Thanks for the talk. I was in another talk which is talking about the cloud events, and I know they're different for different applications. But in your view, there's still something overlapping, right? And you can use either. How you compare them? Thanks.
Yeah, that's a good question, because I just recently started hearing about all of what's happening with cloud events, and so cloud events are meant to be external to the cluster. It's all sort of a part of this, eventing and streaming sort of infrastructure that we can build, so you can have your producers and consumers. Events are meant to live inside of a Kubernetes cluster and reference Kubernetes objects, where cloud events could be more seen as a general purpose API for sending events to other consumers. So kind of you could think of it as like using Kafka or NATS to be able to send kind of general purpose data. At least that's what I understand from cloud events.
Hey, I might have missed this, but what was the relationship between the Python watcher that you showed the code for and the event router and event exporter examples you showed? Couldn't you essentially push from Python directly to your sink, or?
Yes, you could. You could. I was just using the Python example as what's going on behind the scenes. So really, that's what Event Router is doing. Is it's establishing a watcher on events, and then when it receives them, it's routing it to whatever sinks you have configured. And so yeah, you're right. Like you could set it up. There's a number of different ways that you can handle events. You could use the HTTP call to have it talk to your own application. You could set up an admission controller that always returns true, that listens for events, the creation of events. So you get this sort of like, or editing of events. So you could have it make a webhook call from the Kubernetes API. There's obviously a lot of potential for like drawbacks to consider with all these different approaches. But yeah, there's many different ways to do that.
Cool, thanks.
Hey, Jesse, thank you for your talk. Just wanted to ask, sorry guys, all the you talked about two sets of examples of using events. One of them, they're going to sinks and something happens, usually kind of almost a log type recording of it. The other example that you had was, again, like they were temporally independent, seeking approval from somebody or some event, some test passing. Have you seen or considered or think that it's appropriate to use events in processes or to trigger processes that are not temporally independent like that? Thank you.
Triggering processes from certain events that get created?
Exactly, yeah.
Yeah, no, that sounds like a really cool use case. You could kind of think of that being used for something like a auto remediation type task. So if you're not able to capture some of this stuff with a liveness check that kills a pod, maybe there's some sort of event that you emit that you want to kick off something that maybe it's a known problematic query against your database. You could emit an event that would then kick off a job that goes and finds those queries and stops them or something of that nature. So although that does kind of that I think is a good use case for like a general purpose type of event. But you could think of something similar inside of the cluster where if you see this event, you go and you kick off something like maybe, it's pretty similar to autoscaling, right? Like if you see it's watching these metrics and then it's acting on them based on that. So.
Thank you.
Mm-hmm.
Hey, Jesse.
Hey.
So emitting events, does it have any impact on the performance of the cluster? I attended a talk in which Uber shared their migration strategy, and they were trying to create a cluster with I think, more than 5,000 nodes with like 40,000 pods. And just the pod creation events were causing a lot of delays in pods coming up because it was overloading the cluster. So I just wanted to know your thoughts about it impacting performance.
Yes, events, if you use too many events, they can potentially impact performance. This was a problem particularly back in the ETC2 or etcd2 protocol. So it would, a lot of times the scaling solution was to separate out your events into a separate, like an events etcd. But since etcd, the upgrade from 2 to 3, it's improved a lot. The API is a lot faster. It's a lot more terse instead, because before it was all HTTP, and I think it's all gRPC. But it improved the scalability of events and the performance of them when they did that. But it is still a performance consideration. So you don't want to go too crazy emitting events, because yes, it could potentially cause things to back up.
Okay, thanks.
Thanks.
So to the point earlier about sort of driving things off of events, so is there any pattern for sort of at most once delivery, or is this getting them to be a little too crazy, right?
No, that is a good question. And it is something that if anyone who's written an operator has had to consider, or at least understand how the framework deals with that. Because yes, events can be repeated. There's certain things that they're like trying to keep it unique, like the name unique. So if you're storing the state of the event and you're hashing instead of doing what I was doing in my example, which is just generating like a random collision-resistant ID, if you're hashing based off something, that should hopefully prevent you from creating multiple events. But yeah, it's still, just as any distributed system, a real possibility that you could have something that executes based on receiving the event more than once.
Yeah, so I meant on like the consuming side, you could, for example, like add a label to the event and say, I've already done this or something like that. Or would it make more sense at that point to use some sort of general purpose message or Kafka or something like that?
If you're still if you're still using things related to objects in your cluster, I think it still makes sense to use an event. But yeah, you're right. Maybe there's one of the tricks that I've seen used here is adding if you're modifying, say, another object, it was in, I think, Airbnb's talk, they were looking at an observed generation. So when their script was going to do something, or their programs would do something, they would note the generation that they last observed and compare that to the automatically generated monotonic counter for what is in the cluster now. And if it's different, it would perform it and then change. It would change that first and then perform the action. So, but it is totally something to consider. All right, thank you, everybody.